Welcome back. Today we're looking at 4C question 8. And as part of that, it's a multi-step behemoth. So determine the Pearson's correlation coefficient for the R value of the data. So again, you are given R squared. Now, looking at the graph that we've got here, you can clearly see that it is going in a downwards negative direction. So whatever value we get for R, if we do it properly and we get the plus and the minus of it, we need to select the negative value that goes with it. So, in our CAS, solve R squared equals 0.370, comma R. We have two values, negative and a positive, because again, our graph is negative. I can't mirror image backwards things. The R value is going to be our negative value of 0.608. So, negative 0.608. Interpret the coefficient of determination in terms of the variables hearing, test score, and age. So again, this is one of those questions where you have to write a whole sentence for not a whole lot of marks. R equals negative 0.608. B. So the R value is 0.370. That means that's 37% of the variation in hearing test score is explained by the variation in the age. So question C, write down the equation of the least squares line in terms of the variables hearing test score and age. Now, what you'll notice up there is the line is using Y and X. They want you to interpret in terms of the variables. The variables on our graph are not X and Y. They are age and hearing test score. So you need to replace Y with the correct value or the correct name and X with the correct name as well. So in this case, what is our Y value? It's the hearing test score. X is the age, so you need to rewrite the whole thing. So hearing test score is equal to 4.9 minus hearing test score equals 4.9 minus 0.43 times the age. Right, the slope and the intercept. Slope equals is negative 0.043. The intercept is 4.9. All right, remember this comes from Y equals A plus BX. Y equals A plus BX. A plus, well, it's going to be a minus, and we go from there. All right, question E. Using the least squares regression equation, predict the hearing test score of someone who is 20. So we go over to our CAS, we put in our equation, so we want the hearing test score of someone who is 20. So that's going to be 4.9 minus 0.043 times 20. And the answer should come out to be 4.4. All right, the answer should be 4.4. No, 4.04. So that means on our equation here, I 0, so it should be 4.04. Score is 4.04. Now, question, actually, I'm just now that I think about it, question D, yeah. Oh, write down the slope and intercept. I'm silly. Interpret. For each year of age increase, the score decreases by 0.043. That's what that was. That's my mistake. It's called not reading the question, which everybody is guilty of sometimes. So, the residual, remember, for the residual, you want the actual minus the predicted. So the predicted score, the actual score was 4.04. So that's what we predicted. The actual score is 2. Therefore, so the residual is equal to the actual minus the predicted, which is going to be 2.0 because that's what the question says. The question said the actual score was 2.2. We predicted that, therefore the actual value would be negative 2.04. All right. Now, what we need to do is we need to take our data there's our scatter plot there. And question F says use the graph to estimate the value of the residual for the person aged 35 and the person who is aged 55. So let's look at our graph, and can you guys, I don't think you guys can actually see my pointer. on this, can you? Oh, hang on, I can fix this, hang on. Yeah. All right, using this graph over here. So they want you to use that graph there. Estimate the value of the residual for the person aged 35. So 35, this person here is aged 35. Their score is up here and it's down there. So that, to me, looks to be about 0.3. Because remember, this whole thing is 1, and that looks to be a little bit less than a proper third. So I'm going to say it's 0.3. Now, the predicted score is below the actual, so it's going to be negative. All right, the actual score and the predicted are different. The actual score is higher than the predicted, therefore the residual is going to be a negative number.
Wait, Sam, can you point to which one is the actual and which one is predicted?
Yeah, not a problem. No, excellent question. So the red line is the predicted line. And by that I mean... Oh, go away, ruler. And by that I mean this red line. So this red line is the predicted line based on the least squares regression. And based on what we've got here, this vertical distance is about 0.3. Now going to the person aged 55. This person here is age 55. Now their score is below the regression line, not the predicted line. So actual minus predicted. So their actual value is about 2.4, and their predicted score is a little bit higher than that. All right, and so if we go down to question, we're going back in here. F I actual minus predicted equals 0.3. It's about 0.4, but because it's lower than the line, it's going to be negative 0.4. Realistically, if this was a question that you were given on a SAC, if you were reasonably close with your estimation, you would still get the marks for it. Because that graph doesn't have exact delineations between where things are. You might need to break out your ruler, etc. Now, the last question, the residual plot for this regression analysis is shown opposite. Does the residual plot support the initial assumption that the relationship between hearing test score is essentially linear? Explain your answer. Now, the answer is yes, it is essentially linear because there is no pattern. Because there is no pattern, we can therefore say it is linear. All right? No pattern in the residual plot. We can assume the relationship is linear. And that covers all of question. That covers all of the question.
Wait, sir.
Yeah.
So you know how you're saying there's no pattern?
Yep.
What pattern? Like, what do we look for in a pattern?
Well, if you look here this is a residual plot that was made by the CAS. And now it's obviously using some different values. I don't know why their X value and their Y values are different. That's probably because the old version of the text had different values here. But even if we ignore the fact that these numbers are different, because again, this is a textbook question, this is one made by me. If we look at the values that we've got here, there is no pattern. There is no way that I could draw a line, a straight line through any of this and get any sort of line that makes sense. Some things are way above, some things are way below, some things are on the line above, other things are not. It just looks like a random mess of dots. If you were to take the R value of that residual plot, you would find that it's 0.024 or something, which is basically no relationship at all. Alright, it looks like a random mess of dots, which means it probably is a random mess of dots. And a random mess of dots means that the original relationship is going to be linear. Sometimes you will do a residual plot where there is a distinct pattern. That generally means something else is going on.
But does it mean it's non-linear?
It generally means, yes, it is non-linear, and that's when you would do a transformation to it.
Okay.
Okay?